In section 2.3, we're going to work on adding, subtracting, and multiplying polynomials. This is predominantly review for you. The key vocabulary that we have from this section are like terms. And remember, like terms are items that have, for instance, a variable to the same power. For instance, 2x squared and 3x squared. These are like terms. We could also have like radicals. 2 radical 3 plus 4 radical 3 is equal to 7 radical 3. So this would be equal to 5x squared. But when you have items that are not like, for instance, 2x squared plus 3x, these are not like terms and they can't be added together, right? So that's something that you already are pretty much aware of. So in using these skills, we could solve a problem like this one, where we're looking at having two polynomials. The first one, w, represents the number of United States wells producing crude oil, and a second one, o, that shows the oil output per well in barrels. So what we could do with these, right, is I could find out by knowing how many wells there are in a specific time times the amount of output. I could find out the total amount of output in the country, right? So we have number of wells, output per well. And then we could go ahead and find this value, which we'll do later in the lesson, for the total amount of crude oil produced per day. But just getting into practicing some of these things, if we want to go ahead and do subtraction, what I want to do first is I want to take the parentheses off, right? But when I do that here, nothing really changes. But when I do it after a negative sign, it's really the same as multiplying times negative 1. Negative 1 times 4y becomes minus 4y squared. Negative 1 times minus 5y becomes plus 5y. And negative 1 times 3 becomes minus 3. And now I want to combine like terms. I have 4y squared minus 4y squared. That becomes nothing. I have 9y plus 5y. That's 14y. And I have minus 5 minus 3. That's minus 8. Right? If I have a plus sign here, really, the taking parentheses off becomes complicated when you have a minus sign between them. But when you have a plus sign between them, nothing changes when I take the parentheses off. So it's easy to say z squared plus 5z squared is 6z squared. 5z plus negative 11z becomes, negative 16z. And minus 5 plus minus 6 is minus 13. So that's pretty straightforward, pretty easy. So adding and subtracting polynomials is pretty much something we've already practiced in terms of combining like terms. So go ahead and pause the video, do these problems, 3, 4, 13, and 14, and then come on back. Okay, so when we want to multiply polynomials, we're doing the same sort of thing that we did with FOIL. But remember, FOIL is the distributive property when you're multiplying two binomials together, right? But the distributive property basically says I take everything in the first binomial times everything in the second binomial. So normally I'll start with the first one, and I'll multiply times each of these three. So 2a times a squared becomes 2a cubed. That's a 2, I swear. 2a cubed. And 2a times minus 10a becomes minus 20a squared. And 2a times minus 2 becomes minus 4a. And then if I take the minus 3 times all of these, I'll have minus 3 times a squared is minus 3a squared. And minus 3 times minus 10 is plus 30a. And minus 3 times minus 2 is plus 6. And you notice that I've arranged these vertically, and you'll see that I've aligned my columns based on like terms. So now I can just add down. I'll get 2a cubed. Negative 20 plus negative 3 is minus 23a squared. Negative 4 plus 30 is plus 26. A plus 6. Okay, so you can go ahead and arrange things vertically like this. Just make sure that you keep columns for the different powers of the variable. The more traditional way to do it, or at least the way that I learned when I was in school, is I'm going to take these all and multiply them together, but I'm going to keep them as a horizontal string. So minus x squared times x squared is minus x to the fourth. Minus x squared times minus 8x is plus 8x cubed. Minus x squared times plus 3 becomes minus 3x squared. And now I move to the next term. Plus 4x times x squared is plus 4x cubed. 4x times minus 8x is minus 32x squared. And 4x times 3 is plus 12x. Now I've run out of space, but I'm moving on to the next term, and I'll have x squared, right? It'll be plus x squared minus 8x plus 3. When I multiplied everything by 1, they really didn't change. Now I want to combine like terms. So I know that my first and last terms won't have anything to combine them. So I'll have minus x to the fourth. But then I have x cubed, 8x cubed, and 4x cubed. And those are all my x cubed. So that becomes 12x cubed. I have minus 3x squared minus 32x squared, that's minus 35, plus x, so that's minus 34x squared. And I have plus 12x minus 8x, that's plus 4x plus 3. So you can go ahead and do this whatever way makes the most sense to you. Right? You can see that arranging these things vertically might be simpler in terms of keeping track of everything. What's important as you sift through these guys is that you do one power of the variable at a time so that you're combining like terms, and make sure that you don't skip any. So that's why I like to underline them as I go, make sure that I didn't make any mistakes and miss anything. Okay, now that was multiplying two polynomials together. Here we would multiply three polynomials together. And it's really no different. It's just take the first two and multiply them together. So z times minus z is minus z squared. And z times plus 2 is plus 2z. And minus 4 times minus z is plus 4z. And minus 4 times plus 2 is minus 8. And I'll combine like terms. So I'll have negative z squared plus 6z minus 8. So I've taken my two binomials together, and I've created a quadratic function. And now I'm going to bring down the third binomial, z plus 8. And I'm going to multiply it times all these things. So minus z squared times z is minus z cubed. Minus z times 8 is minus 8z squared. Sorry, minus z squared times 8 is minus 8z squared. 6z times z is plus 6z squared. And 6z times 8 is 48z. And negative 8 times z is minus 8z, and negative 8 times 8 is minus 64, and now I'm going to combine like terms again. So I'll have minus z cubed. I have negative 8z squared plus 6z squared is minus 2z squared. 48 minus 8, that's going to be 40z, and minus 64. Okay, so when you have more than two of them, just take two, either two, right? You can pick, if you thought one pair or another was easier to multiply, then go ahead and do it. I multiplied these two together. That made this quadratic function. And then I brought this third one down and multiplied it out. And so we just do it a step at a time. Okay, so again, pause the video. Go ahead and do problems 16, 18, 20, 28, and 29 as practice. And then come on back to finish up the video. So we've already learned earlier in chapter 1, we learned the sum and difference, so the difference of two squares, right? So multiplying conjugates together. We learned about the square of a binomial. And we did all this stuff in chapter 1. Now in chapter 2, we're continuing on, and we're just looking at bigger polynomials. And now we're looking at the cube of a binomial. Right? And what's important for you to notice in the pattern for the cube of a binomial, you'll notice that, right, we'll have this sign happens here at the beginning and also here at the end, right? The signs are what changes. The other parts of it don't really change. Okay, so they'll be reflective of what's in the middle of the binomial. Okay, it's very similar to this pattern, except now instead of 2 in the middle, we have 3, because it's matching the power, you'll notice, that we're doing. And so what the benefit for us is that rather than actually taking these 3 binomials and multiplying them together, instead I would just follow the pattern, and it'll be faster for me to go ahead and work that through. So for instance, if I know that A is equal to 3z, and I know that B is equal to 7y, and I'm working with this pattern, A plus B cubed is equal to A cubed plus 3A squared B plus 3AB squared plus B cubed, I can take A and B and plug them into this. 3z cubed plus 3 times 3z squared times 7y plus 3 times 3z times 7y squared plus 7y cubed. I didn't manage my space very well. 3z cubed, I'm going to cube 3. 3 cubed is 27, and z cubed is that, it's z cubed. Plus, here we'll have, this is going to be complicated, I'm going to have 3 squared, which is 9, times 3, which is 27, times 7. So 27 times 7 is 189. So I have 189, and I have z squared and y. And we move on to the next term. I'll have 3 times 3, which is 9, times 7 squared. So we'll have 9 times 49. So we'll have, that's 441 z y squared, and then we'll have 7 cubed, so that's 7 times 49. That's 343. So we have 343 and then y cubed, which is y cubed. So it took a little time. These are some awkward numbers, but this is about as difficult as this type of problem gets. I just follow the pattern, simplify each term one at a time. I did this all with a pen and paper. If you did it with a calculator, I'm sure you'd go much faster than I did. Okay, so a couple practice problems just to make sure you know how to do it. 16, 18, 20, 28, and 29. Oops, I'm sorry. So a couple practice problems just to make sure you've got it right. 38 and 44. And then come back and we'll finish out the word problem. Okay, so here's our problem. As we talked about in the very beginning, we know that this function, W, is the number of wells producing oil. And this polynomial, O, is the output per well. So if I want to know the total, right, the total amount of crude oil, that would equal the number of wells times the output per well. So that's going to equal negative 0.575t squared. Oops, excuse me. Plus 10.9t plus 548 times negative 0.249t plus 15.4. Okay, so I'm multiplying a trinomial times a binomial. And when I go ahead and I go through that, I'm not going to show you absolutely every step, but I get 0.143 t cubed, cubed, minus 11.569 t squared, plus 31.408 t, plus 8,439.2. So this is going to be my total. Okay, and that's great, but that's for crude oil produced per day since, right? My T values are years since 1980. So the year 2000 would be 20 years later, 20 years after 1980. And if I want to do this, then I'm going to go ahead and I'm going to do synthetic substitution, right? So I don't really want to plug 20 into all of this and simplify. But if I take my coefficients, 0.143, negative 11.569, 31.408, and 8,439.2. And I'm going to go ahead and I'm going to multiply it times 20. Right, so this becomes 0.143. When I multiply it times 20, I get 2.8635. When I add those together, I get negative 8.7056. When I multiply that times 20, I get negative 174.112. When I add those together, I get negative 142.704. And when I multiply that times 20, I get negative 2,854.08. And when I add these guys together, I get 5585.12. And this is my output in the year 2000. So what we did is we focused on multiplying polynomials together, and then I went to a different skill, the synthetic substitution, in order to go ahead and solve this more quickly. If you had wanted to plug the values in and do direct substitution, you certainly would have been able to do that, and that would have worked just fine.